Alright, so I think I'm recording. We have a rational function here. I know it's a rational function because the numerator is a polynomial and the denominator is a polynomial. The numerator is a polynomial of degree 3 with the leading coefficient of positive 1. The denominator is a polynomial of degree 3 with the leading coefficient of negative 3. My first step with a rational function is to factor both the numerator and denominator. So I see that in this numerator, both of these terms have an x squared in common. If I factor out an x squared, what I'll have left is x to the first power because 2 plus 1 is 3. And I've taken away that x squared so that I'll have a factor of 3 here. In the denominator, I like to have positive leading coefficients. And both of these have an x and both are divisible by negative 3. So if I factor out a negative 3x, what am I going to have left? Well, the negative 3 has been factored out, so I'm going to have x. Originally I had 3 factors. I pulled one of them out, so I have 2 remaining. A negative times a negative is positive, and 27 divided by 3 is 9. And I factor that x out, so I have this. Alright, so I've got x squared times x minus 3. In the denominator, I have a negative 3 times x. X squared minus 9 factors to x minus 3 times x plus 3. So here in factored form, I'm ready to state my domain. My domain is a set of all real numbers, excluding 3 values, because there's going to be 3 different values that cause this to be division by 0, and I want to avoid that. Have to avoid that. If x is equal to 0, it's going to cause us problems, so we throw 0 out of the domain. If x is positive 3, same idea. 3 minus 3 is 0. We have a 0 in the denominator. So we throw 3 out of the domain. And we throw negative 3 out of the domain. The same reason, it causes division by 0. Now, each time something thrown out of the domain from a rational function, it will appear in the graph as either a whole or what we call a vertical asymptote. Can't be both, and it has to be one or the other. So now we look at this function in reduced form. We cancel the common factors. Alright, so what cancels here? Well, we have a factor of x that cancels, and we have a factor of x minus 3 that cancels. So this 0 that was thrown out of the domain, because it had a common factor in each numerator and denominator, we say that it's going to create a hole in the graph. This x minus 3, and remember 3 minus 3 gave us 0, that this x at x equals 3, it's going to have a hole in the graph. So I have this 0 comma y, and I have this 3 comma y that are going to be holes. Now what stayed in the denominator was x plus 3, and negative 3 plus 3 gives us 0. So this guy is going to be a vertical asymptote. We always have to write it as an equation. It's the line x equals negative 3. Alright, so I'm almost done. I've given them the domain. They wanted that. I've identified that this graph is going to have 2 holes, and it's going to have a vertical asymptote, but I've given them the equation for the vertical asymptote. I just have to be specific on the location of each one of these holes. I need to continue with this function and reduce it and write it in lowest terms. Both of well, no, I have an x right there. I almost lost that. Only one factor of x canceled. Remember, this was x squared, so it was x times x. So I have an x in the numerator, and in the denominator, I have this negative 3 times this quantity, x plus 3. Alright, now that's what f of x is. But remember that f of x is just function notation for a y-coordinate. That's what I'm wanting is a y-coordinate. So if I let x equal 0, let's come over here. If I let x equal 0, I've got 0 divided by negative 3 times positive 3, because 0 plus 3. And 0 in the numerator is okay. 0 divided by negative 9, that's 0. So I know that this hole in the graph, or at least one of the holes in the graph, is at the origin. The graph does not pass through the point 0, 0. It has to jump over it. 0, comma 0 is a hole in the graph. Now what about when x is 3? Well, let's come into this reduced function and see what this y value is. So x is 3. In the denominator, I've got negative 3. 3 plus 3, because x is 3, is 6. All right. So I've got 3 divided by 3, which is 1. So I have negative 1/6. All right. And we're done. They wanted the domain, and it was all real numbers except 3 values. And these 3 values appear in the graph as either a hole or a vertical asymptote. There are 2 factors that canceled. That's a negative 1/6. 2 factors that canceled, so therefore there were 2 holes in the graph. We found that the coordinates of one of the holes is at the origin, 0, comma 0. The location of the other hole has coordinates 3, comma negative 1/6. And the graph, the vertical asymptote, at x equals negative 3. So our graph, these 3 values of x will not have corresponding y values, and so that's how they appear in the graph. You can go to that Desmos graphing calculator, graph it yourself, and kind of check out and see what it looks like. Hope that helps with number 2, and I'll talk to you later.